Okay, so the idea is that we are presenting you one of the things at demo scene that are important to create productions, and this is a code. Of course, coding is not the only. You can also be a musician, you can be graphician, you can do many other things. But let's start to code and do something. Okay. So now the basic idea of this technique that I will present today is that we are writing pixel shader. What pixel shader is, just to recall from yesterday, is a short program that runs on each individual pixel of your image, of your rendered image. So this is a special program that is put into the graphics pipeline so that you can adjust the color of your image. And these pixel shaders are important because with the development of recent GPUs, you can really have enormous power, and you can write very sophisticated algorithms that run in real time. So today what people do, they are writing simple programs and create pictures like on the right-hand side that you can see the textured, three-dimensional, lightened, transparent, foggy scene which run in real time. So it's like running of a demo scene or graphician dream of having a real-time ray tracer. And this is something we will touch today, okay? I'm not going to really give you like a regular lecture. We would need like 12 lectures to go through the fundamentals, and I would need to prepare for half a year to give it well. We will do really basics to give you some flavor how to start, and really after this and after next event in Forge, you will be able to start coding something, okay, in this direction. So these are pixel shaders. So yeah, that is how you can imagine. What is the message here is that each pixel runs the same program. There is no diversity. You have to run the same program at each pixel. So how does it happen that this pixel is white and this pixel is black, or this pixel is yellow and this pixel is green? All this happens because the pixel knows the position. From this position, you can, for instance, cast a ray in different direction. Having the position, you can cast a ray and compute what is the color. Okay, these are the basics. So this is the basic structure of the program. So for each individual pixel, just do something. Okay, this is what we will feel during this lecture. Okay, and there are three techniques I mentioned yesterday, and we will now go into details of these techniques. First is about creating basic shapes and colors just by taking the position of the pixels on the screen and computing the very simple transformations. Second are the deformations of textures. It's something like called planar deformation. So we will take a textured two-dimensional picture and just adjust the coordinates of texture with some continuous function. This all may sound a little bit scary to very like beginners, but don't worry, I really present the things that are accessible. And the third part is ray merging. And to be honest, I was actually thinking a lot whether to present it or not, because this is not easy technique. So the idea here is, don't worry if you don't understand much of what I'm trying to convey, but I want you to go out from this room with a knowledge that the shaders may have been used to compute the ray-traced computer graphics in real time, and with some basic knowledge how to start to really like understanding it, okay? So this is about ray merging, but you will also work with it if you come to another part, okay? Yeah, let's start. Part one, shapes. So we'll now start to code something very, very simple. And this is an example of simple shader that we have to now really, really concentrate and try to understand. So this is something you have to now consider that you understand everything. And now, don't worry, raise your hand, ask question. I will be very happy to answer now, because every question you have now probably fits to other people in the audience. So don't worry if you feel like not asking because maybe it's too simple. No, there are no simple things now. This is fundamental, important. Try to understand. Okay, this is basic shader. This shader produces image you see on in this black window. So it's basically black color. What happens here? So the main image is a function. It's a function of this shader. So basically, it takes two inputs. It's a fragment color, which is sorry, this is not input. This is an output variable, fragment color, which you have to set in your shader. So if shader basically set a color to some like 4-dimensional vector, it sets its red, green, and blue coordinates. So basically, if we do, in our shader, we set color to 0, 0, 0, means this is black, red, green, blue. It's easy. To people who didn't work with shader languages, this is GLSL shader language. So it's from OpenGL, originates from OpenGL. And it's pretty simple if you code in C or C++, because it's a structured code. You have some structures you can use. So for instance, what we do in this third line is we declare a vector of 3 coordinates, which is called call. This is just a variable which has a structure of x, y, and z. And this x, y, z will be later on used to create 4-dimensional vector with these coordinates 0, 0, 0 here, and 1, which is just passed through. This doesn't matter in this shader. Yeah. Sorry? Yeah, it might be used as alpha, but in this ShaderToy we will be using, this is omitted. This is just not important. So we just put it 1. Okay, you may use it as an alpha, for instance. That's a good point. Okay, so now we have this basic shader, and this frag chord, this is an input variable. It is passed to our shader, and we will be using it later. What is that? This is just to finish my thought. So this is a coordinate of the pixel for which the shader was run. It's important because from this coordinate we can calculate something. Yeah, there was a question in the second order. Yeah. Just to make the later code more clear. You are right, we can omit it. You can just put the vector for 0, 0, 0, 1, and that will be fine. So you may write it in one line. You are good at optimizing code. Okay, now, did you want to say something? Yeah? No? Okay. So now we continue. So this is basic shader. Now, I will now just ask again, any questions to this one? Okay. Okay, I'm just initializing vector with this vector tree. So it's like in object language the constructor, but it just put these numbers in. This in and out, this is just for you to know which variable is input, which is output, to understand what is put to the shader as after you run it, which one is that you have to set at the end, okay? And that's it. It doesn't change. This is like fundamental for ShaderToy, shader effects, and you always have those two, okay? It will not change. So we will work with this, okay? So we set frag chord, color, and we have frag chord. Okay, so now let's move on, and I think if there more question comes, don't worry, ask. This is right point. It's good time. Okay, so now let's run the ShaderToy and do some very basic stuff so that you see how it works in reality. So now we have our ShaderToy run. I will just enlarge so you can see more. I hope this is now visible. So now this is ShaderToy tool. It's a web page created by Iñigo Quilez and Paul Jeremias. People who are working with shaders for years. They're really big persons in this community. They created this tool and actually succeeded in creating community of people working on shaders, and now we will become one who can also do something with it. So this is our basic shader I just showed you in a second before, and it works in this way. You can work with your shader on the right-hand side, and you immediately see effect on the left-hand side. Okay, not immediately. You have to click like push Alt and Enter to run it and send to graphics card. So let's play with it. We have this color variable, and we can change the color. Okay, it's maybe not very fancy, but let's do some nice color here. So we will put some 0.5, 0.8 for red, green, and blue. Okay, so we just change the color of our shader. We can play with it in different ways. We don't have to just put numbers. We can multiply them, for instance, by 6. And this is the moment that I didn't plan, but I will do a mistake. And this is what my students at university loves when I do some mistake I didn't know. So then I get into troubles. So yeah, we have a mistake here, and this is how ShaderToy works. It shows you some error comment, so that you can read, and usually no one reads but tries to quickly solve it. So I already know what is the problem. The problem is I wanted to multiply my shader by my vector of color by 6. This is wrong. I should multiply by 6.0 so that it's a floating point. Of course, it's stupid by 6 because it will become like this. Let's multiply by 0.3. So it gets darker. We can multiply by 0.5. It gets lighter. Okay, and now we can start playing. Okay, now I'm improvising. I didn't plan to introduce the time variable now, but I will do this so that you can see that you can even give a talk with ShaderToy. It's a toy. It's you can do it very easily. So now let's invent something. I will do like flashing screen. Okay. So I will use sinus function, a mathematical function that is periodic. So I multiply by sinus of the variable I time. The variable I time is a variable that is available for the shader in ShaderToy. Okay. Authors of ShaderToy just put this variable for you. So it's like a variable that you may use. It's a variable that starts from 0 and continues of, for instance, you have it here, it's 180 already. So our shader will run for this time. If I multiply by sinus, it's a bit silly because it will become negative. So I have to add some number like 1. Okay, and divide by, I don't know, for instance, 4. Okay, now let's run it. Now it will be changing in time because my time variable changes, and my sinus is now modifying the color at the time I'm running the shader. Okay, it's not funny, let's do it faster. So 4.0, you see it's really simple. Okay, but let's do it like MAGFest style. Okay, so 14, no, 14, 4, my son is like this. Let's do like this, yeah. Okay, so now you see, and this is of course nothing very. So let's go to SoundCloud. Okay, SoundCloud. Why not? Okay, well, just shout some music. I don't know what author do you like? Sorry. I don't write it here. I don't. Can you? Okay, A. Okay, any machine. Come on, I don't know what is that, but let's take it. Okay, we don't know what is this, but let's have a look with our shader. I don't know. It's more funny than what you wanted. It's not what you wanted, yeah. I'm sorry, I'm not hearing very well here, but there is an input from SoundCloud. Okay, you can just track URL, click here, and make it fun with some music. Okay, now we will see. It's whether it's. Okay, it's music now. Audio not available. No, it goes here, yeah. Oh, it should have been somewhere. What? Okay, it would.
This is Exchanges at Goldman Sachs, where we discuss
Okay, yeah, you can do.
industries and the global economy.
You can do rave demo with it, no problem. Okay, so now you see, in 5 minutes, I did something you can upload for our contest. Just choose the right music, do some little simple stuff and submit it. Really, people do that, okay? This is the idea. Okay, now to make it more advanced, we of course need to choose the right music and know what to type to SoundCloud, but also we can go further with some graphics effects. So let's go further and use the input, which is the fragment coordinate. So now, if you run your shader, as I told you, you have this variable that you set. This is a color, output color, but you also have the input, which is the position of the pixel. And this input is positioned in the space coordinate of the picture itself. So it goes from 0 to the width and height of the picture. Now, of course, it's so this fragcoord.xy simply gives you the two-dimensional vector of x and y coordinate of the pixel. What we do to actually work with it, because you know the picture may scale, so you can have like from 00 to 320, 360, whatever. You can have the full HD, you can have even more. So it's better to divide this vector by resolution. If you divide it, you have a coordinate system from 00 to 11. So 00 is position of the pixel on the left top, left bottom corner. 11 is the right top. What does it mean? That means that if I run my program, this program may use this coordinate to modify the color. So you may do something like that. You have the X position 00 on the left-hand side, and you have X position 1 on the right-hand side. And you can basically use this to modulate the color. Yeah. So let's, sorry, yeah. So let's use it, but before we go into this, we may also use the position, for instance, to calculate the distance from some specific point in our space. So, for example, and this is a very nice example because you can get a circle, which is, you know, fundamental in for many things. You can calculate the distance from the middle of your picture just by using the length function. And this is nice about GLSL because it has many functions which are actually very useful for graphics and for effects like this because they are implemented already. You don't have to implement your own length function, which you would do in C, C++, whatever. Now, there was someone who wanted to ask something. Yes? This is ShaderToy variable. You are right. The ShaderToy is a wonderful tool because it provides a set of variables that are useful for like usual Demoscener coder that are in things like this. Of course, if you wanted to write your own like demo based on shaders and take the ShaderToy effect into the demo, you would need to re-implement some like input variables, which is not that problematic really. These are simple things. But you have them here, this is done, you just run the web page and you work. Yeah? And actually, to be honest, because so I'm not the ShaderToy author, I'm a user and also developer of effects like this, but to be honest, I learned a lot even from this set of variables offered by ShaderToy, what is important, what I could do, how I can work with that, okay? Because these people were really, really very very experienced. Okay, so this is the thing we will be also doing. So now let's go into this simple thing with this ShaderToy. Okay, sorry, this was already done, but I don't want to go like this. I want to go like from here. So let's write some simple gradient of colors, which is actually very fun and funny and yeah. So let's do again the kind of now the colors. It's not nice that light. Let's do it darker and darker. Yeah, of course. Thank you very much for remind me about this because I see it nicely. Okay, so now we have this color. There is no gradient yet. We will be using this position of the vertex. So let's calculate the position, which is two-dimensional vector of our fragment coordinate. So frag coord. Sorry. Our position P will be equal to frag coord. Okay, dot xy. Okay, this is xy is like just taking out the x and y component from this input vector, which already is two-dimensional, and we divide by eye resolution. For mathematicians, this is terrible probably. Is there any mathematician on this lecture room? Okay, because we divide vector by vector. What does it mean? Okay, so that means it's a component-wise, yes? You just divide, it's like in MATLAB, okay? MATLAB does things like this with dot divide, yeah? You can do component-wise division. So now that means that x component of frag coordinate is divided by x component of the resolution and y component as well, and you put it into two-dimensional vector. Okay, so we have P. Now we can multiply by P dot x. It was already in the talk, so we have this gradient from left to right. It is maybe not that nice if we have it dark, so now we can make it lighter and even lighter. Okay, so it's like that. Of course, okay, I'm a bit bored with these colors. Let's do like this. Okay. Okay, so we have, let's make some, yeah, color colors, yeah? Ragazzi. No problem. I can do it for you if you like this. It's it didn't even make any trouble. It's yeah. It's so what happens there? It's clamped into one and it works well. It's the way that graphics card is actually like converting it into the color. So you may get into troubles if you do something not like usual here. But for this computer, this system, this ShaderToy, this fragment color, blah, 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 it works, okay? So don't put negatives to, I don't know, conversion, to number conversion functions and so on, because you may get into troubles with some other. So it's better to keep it like reasonable, yeah. But, yeah, so, okay, red is maybe better. So now we have the red gradient. It's not fancy, but we may, of course, go beyond. We can do y, okay? We can multiply y by x and so on. We can even do in different way. Let's just put it here. So y will be red, x, this is my favorite, and px times py. So what we will be seeing now in a few seconds. Oh, wow, 24 bits graphics, real-time, blah, blah, gradient, yeah? It's already done with our shader. Now you can imagine that you can use iTime, sinus, and basically move, switch, translate your PX, do whatever you like, and this will become like the first Demoscene effect ever. So it's like a plasma effect with colors. You can also, if you are Amiga fan, you may imitate copper list, like bars with colors with this technique, and you may do really simple intros with this simple technique of gradients and using position of your shader. Now I will go into shape, which is now try to concentrate, because this is important part, because the way many of other shaders are done and many of other techniques works is to actually create shapes from so-called mathematical distance function. Distance function is a mathematical function that for given position in the space in your coordinate system returns distance from some other object. Yeah, it sounds very simple, but what people may do, they may, for instance, create a distance function for three-dimensional object. So that, for example, I have this bottle of water and I'm somewhere here, and there is mathematical function that may tell you that if I'm here, this is the distance to my object. If I'm here, this is my distance. And if I have this distance, I can color this on the screen. And this is how the next technique works. So I will now try to draw you a shape of a circle just by taking a distance from the center. So now let's calculate. So let's move on with this calculation. I will now calculate the length of a vector, which is a difference between the middle and my position. That means that for this fragment, this will be this size. For this fragment, this will be this size. Yes, if I will be at the point I'm calculating, I will have 0. Okay? Yeah, so let's calculate it. So this will be float d is equal to the length of the difference between two vectors. One is the vector of my middle, which is 0.5, 0.5. And the other is the vector of my position, which is basically p. And that's it. This is d. And okay, so if I have d, now I can use this d to modulate the color. And now let's modulate with, okay, let's modulate our gradient. Now, it's many things are invented during the talk, you know. It's so yeah, now we have it was actually in the when I was preparing this, it was a gradient which was gray. So well, we have colorful. We are lucky. Now it's not nice gradient because it's dark in the middle, which is not not what we would expect. We would expect something like white in the middle. So now let's something like this. Oh, it looks better. This is what actually we can multiply. You can do many things with that, like multiply twice or three times. It's more like a light now, which is lightening the color. Okay, and you can of course move the point you are calculating this. So let's use this sinus I time times okay, MAGFest style. Okay, 0.2. Okay, now we will have a shaky, or we don't. Something is wrong. Okay, I multiplied by integer value, which is not possible in GLSL. So now we have this, So again, I would put the music, but I'm not very good at choosing the music. So you have to try it on your own. So now you can, of course, put some input. Okay, there are authors of ShaderToys who solve the problem for me because I can use. Okay. It's much better than my choice, So basically, you have this. So some input is available here. You have some textures, music. You can basically use it. Of course, you can do much more with it. You can use ifs. You can divert the code. You can use this time to make like one effect after another just by doing if my time is larger than 10 seconds, then do this. If this, just do it. Go for it. Because I didn't tell that, but the idea of this panel is also to bring you to another one and then to attract you to the competition we are doing here. So you may create it on your own, submit to us, and we will evaluate it, and there is a prize. So not very large prize, but you may be the first one. You may be the first one to win the MAGFest shader competition, the most seen competition. So you are welcome. You can do it today. Okay, let's move on. So we have this. Okay, so I did some playing with these colors here just to make the circle. And to make a circle, now I will just open the code that is already written because I closed my web page by accident. I didn't want to actually do that, but let's now move on with this. So now we have code written before. Now we have to understand it. Don't worry, I'm a lecturer lecturing programming, and I have a lot of problems understanding basic code of my students. It's terrible work. So now So now you have this task of doing that. So let's now go into what happened there. That we have this distance here. So we have an exponential function. Look here. There is an exponential function which takes as an argument the length of the vector, which is a distance from the middle. What does it mean? That mathematical function is doing like from 1 to something below. And this is why we have a white color and then it goes down. It might be done easier with a smooth function. And now I changed my mind. My colleague told me we are at the half time, so it's not bad. We still have some time to do that, and I think it will be worth to show you some nice GLSL function that will be useful for your shaders. So let me just quickly go through this again, calculate the distance. Okay, so now I will stop talking and try to make it fast, okay? So you see, it's happy coding. Yeah, we did it before in different way. Now I multiplied by d. Come on, but it will be still the same. Now the vector 3 syntax error. Okay. Now we didn't have declared p, so it's. Okay, now we have this, and this is our distance function, but we want to have a circle. That's what I'm going to show you. Why circle? Because this is a basic shape, and with this technique of distances, you may also do quads, triangles, ellipses, lines, all the stuff that you need to create, for instance, some logotype or anything like this. So it's like vector graphics with mathematics. And now to make out of the gradient some kind of a circle, for instance, you may use a smooth function. Smooth function is a function that is a step function from 1 to 0, which steps at some point, specific point in space, with a smoothing of the values. So now let's use it. So let's calculate like this smooth, which will be basically smooth step, which brings us from the value, for instance, 0.2 and to 0.25 on the variable d. Okay, so what do we input into step function? I'm sorry, I don't have I just have a mirror so I can watch myself, not write something. And, well, I would write something now for you. Now I will just describe by words. So what we put into smooth step function is the value that changes from 0 to 1, which is d. Yeah, this is this value. And also the point at which the smooth function has to start decrease, and the point at which the step function has to be already 0. So the width of the step function will tell you how much is it smooth. So now we will be able to do a smooth circle. Okay, okay, and just to show it, so we use this smooth instead of d. Okay, this variable. Okay, nothing happened. Now I'm in trouble because it doesn't work. So now, yeah, I have no idea why. So now let's start figuring out. So we have this smooth, which we use to multiply by. Okay. Okay, now it's better. Now I'm less in trouble. So that means now I have a smooth transition from 0.25 to 0.75, which is somewhere here. And let's make it like 0.75, 0.5. Okay, better. So we are getting closer. 70, this is of course wrong, but if we do this, we have a circle. Don't worry, aspect ratio is wrong. This will be corrected later on. Of course, we have to multiply x variable by some value so that the screen, which is not quadratic, gives you the right shape of the circle. So then we have an ellipse. We can hack it just by doing px times equal to 1 point. The better way will be provided later, but we can do like this. Okay. Let's do some sinus I time. Yeah, I time times 14,000. Okay, even more. Oh, wrong. Yeah, no, wrong. Something is wrong. Dot zero. Yes. Now you see it. It's too fast for this shader and the video to make it. So let's do it now in the way. Okay. Yeah. Okay. Now, of course, you can do with with something like this. Yeah. Anyway. Yeah. Okay. So you see, you can do many things with this. You can deform this vector. You can deform the point you are calculating. You can even do much more with this technique, and you will be seeing some. Okay. Ah, I see. I could do that in a few hours, not one. Okay. Now this was the step function, so now you can visualize how this looked like. Okay. And the circle. Yeah. So this is now written in a better way. You will get this presentation from me if you like. By the way, you will have some download link at the end, so you will be able to study it more in details. At this slide, you have this circle in more appropriate way. So you have this mathematical function, which is a step from for the circle at the diameter r, which is a length of this difference between the position of the fragment shader and the middle of the circle r. Okay, and you can use this function just to color, yeah, by variable f. And this is the same we were writing before, but it's not smooth. So this is like a step function at the distance r. Any questions? No. Okay, so this is the same, but with a sharp transition. And if you put a smooth step here with some r plus 0.02, you will get a smooth circle. So this is a better way, and this is a way shaders work. They create the functions for various shapes, and they use them together. So you can add, I don't know, circle to quad, divide by triangle, and get a circle connected to quad without without triangle, for instance. Yeah. So you may do things like this. So you have a circle, you have a smooth circle, and you have a flower. And what happened here with the flower? How does it work? So let's go here. So we have a now we have a circle, yes, and we. Okay. Yeah, of course. I will now. Thank you. Yeah. So we have a circle. Now the circle is a little bit better. You've seen I've hacked the aspect ratio. Now here is a, I wouldn't call it magic formula, it's very simple, but I would need a whiteboard to explain, so you have to basically take it and just calculate what happens here. I moved the coordinate system from 0, 0, 1, 1 to coordinate in which the aspect ratio is right, just by multiplying by I resolution x divided by I resolution y. So I multiply my vector, which is a position of the vertex. Don't worry, this is, you sit down with a paper, 5 minutes, and you understand it. So we have the position of a vertex, which is right, and now we have the circle, and the circle is from this function. And now what you could do is to, now I will not code this, because this will take us more, control 5. Something happened to my presentation. So, it's already presenting, thank you. But where is it? Okay. Yeah, thank you. That was a good point. So now, for each individual position of your vertex, you can calculate the angle between the line that connects the vertex to the middle of the screen and between the x-axis, for instance. By calculating this angle, just by taking Arcus tangents function. Don't worry, these are like trigonometrical stuff, but from the high school. You calculate an angle just by doing one mathematical function, calling Arcus tangents, and having the angle, you may adjust this distance with a sinus function. What you can see here is a flower that is created by adjusting the distance by taking a sinus of this angle. And by increasing frequency, you can do the flower even more. And this is what people are achieving with this technique. Yeah? So these are shaders created with these distance functions, and there is nothing more that I told you, with some, of course, nice algorithms for giving a light to these parts of the objects, but let me just show you some examples of what people created. So this is a creation by the author of ShaderToy, by IQ. It's not the best shader of his creations that you may see in this ShaderToy tool, but it shows a very simple technique with descriptions and everything. And one thing important for you if you want to start working is that even authors of ShaderToy says that don't worry, this community is for people to learn, take the shader, learn on it, change it, do something with it, add something and publish there. If people do that, and this is the idea, people work here and develop these techniques. Yes?
So when you declare the background, vector 3 color, and the vector there's only one number in there, when you do that, does it make all three vectors the same?
Sorry, I did. Okay.
Right there, where it's background.
Yeah, background.
Vector 3 color, vector 3, and then that's just one number.
Yes. Yes.
So it makes them all the same?
Yeah. This is how it works. It has a lot of things like this in GLSL, which are actually put to make the life easier. But you need to, of course, you need to practice a little bit to understand how it creates these things. So it can create a vector from two-dimensional vector, comma, 2, and then do 3 dimensions and stuff like this. Yeah. So it is more like object programming without declaring objects here. Yeah. Yeah. So basically this stuff is simple. You already seen this. You have these lengths, you have power functions, you have sinus, you have time, you have nothing more than I told you. You have smooth step, which IQ is using heavily, and you have nice colors, okay? There is no music, this is not like an effect, but just to show you the technique. Okay, so now let's go into this, following shaders. Okay, so now we have this. This is also, I want to show it because it's really, really very simple. Again, it's very simple stuff here, and you have nice, more game-like effect. Of course, you can make it full screen. For this will be even a little bit faster. Okay, so yeah, you have this simple. Oh, but this is very simple. But people do stuff like this as well. So this is a lot of work, I guess. Basically, how many lines is that? This is mathematical function. Okay, 200 lines is not that much, but the shader is lovely. It is of course real time. I can see. I just click here. I move it. It works in real time. It's okay. Okay. So it is vector graphics, real time, written as a mathematical function in a web browser. Okay, as an effect. And this is something I wrote by myself. It's not the best example of shader writing, but I spent really a lot of time on it because I did it for my children when I was having I was preparing for a party and I created it for a competition. It didn't win, it took like 7th place, but the shader is really, really very heavy. Now it's compiling and it's sending, okay. So we have it, it's a Peppa Pig. Anyone knows what Peppa Pig is? It's a favorite for my children, and I wanted to show it just to show you some application of shader that you may use. So I'm using it, and my children love to play with these shaders to change something, because all this is a mathematical function, and I don't say about Peppa Pig. You know, you have this many things here at MAGFest you might do different, better than Peppa Pig. But you may, for instance, sit with your child and say, okay, so what do you want with, I know, Daddy Pig, yeah? Oh, I want a second Daddy Pig. Okay, let's do a second Daddy Pig, yeah? So this is really nothing else than by changing one function, which is here at the very end, because I have my image, which is basically Peppa. I take one of this, I copy it, and I add another Daddy. I will not do that now, because I will probably put myself into troubles. This laptop is very slow for this huge, really very heavy shader, but I will show you what my children made. And these are the shaders created by Bartek, which is 2 years old, Robert 7 years old, and Karol 8 years old. And of course they didn't sit and program by themselves, but they are sitting with me on my knee and says what they want to create, okay? So you will see how this children mind develops in time as well. But what is important is that we have a lot of fun, and what children get is they get a little of programming. Just a little. They know that if I want to make the Peppa Pig larger, I multiply by some number. If I want to move it, I use sinus function. And of course, I don't even try to explain details of it to them, but they are like seeing the right-hand side editor and effect on the left-hand side. I would say that because I love the idea of code.org webpage that which teach children to program, this is even on the lower level, I mean, more accessible, but what is important is that you have a parent, and you have a parent who understand a little bit of shaders, and so now you are very close to do that and to have it. If you have children, you understand how nice is that to have something like this so that you can easily attract them to, for instance, programming. And this is a very beautiful shader I wanted to show with this technique from IQ. It's done with a simple distance function by IQ. Now we will speed up a little bit, and don't worry, because I wanted to make my best to give you this simple ShaderToy introduction first, and then you will get a fast overview of another techniques just to give you a flavor. Not really very important to go into details now. We will also have the time to convey it at the workshop. So we have 10 minutes. I think it's enough to get a clue. So that was a shader by IQ, this famous person in the ShaderToy community who actually develops the whole idea. But there are much more from him, you will see in a minute. Now the second part is deformation. It's a simple technique that originates from Amiga and other computers which were used in the demo scene, when you basically have one single texture on a screen and you modify the position in texture coordinates, on position of texture coordinates. So you basically have a program like this, so you can now see on the below that you have an image. Yeah, you have this input and output and input the same. You calculate the UV is the same variable we have it called P before, like the position in the on the screen. But now we use it to take color from the texture channel. So you have the I channel 0. So coming back to a question from audience, which was very nice because already explained. This I channel is provided by ShaderToy. It's a channel in which the texture is already available. So you basically click, you put the texture in, don't worry, you have an I channel to get the texture from. And you use the UV and I time to deform it. And what you can do with this is very nice because you can now modify this UV with, for instance, distance from some point. You can modify with an angle and you get something like this. These are effects known in the demo scene. So for instance, if you modify by, this is just position, so the UV of the texture is positioned in the screen. There is also something you can get the absolute value, you get the things like that. And let's just go quickly through this. I have it already prepared in a way that I just uncomment the code. You can get all of this from me, so you can play by your own. Don't worry, this is the knowledge, it's free. So yeah, we don't have an internet now, so we will not probably go through. Yeah, don't know what happened. Let's try again. Okay, it's not good. Okay, these are creations by done with this technique by IQ. These are nice because they have nice colors, and I'll just again try to open it. Maybe now it's working. I don't know what happened. Okay, let's move on. For the people interested to see how it's in the ShaderToy, you will get the links from me, or you can also get, basically come to the next part at 1:30, Baltimore 1:4. We will have the following workshop, at which you will get the hands-outs from myself, so that you can basically go through 1, 2, 3, 4, and so on points, and step by step introduce yourself into these 3 techniques that we are already discussing. So you will have it like done, okay? And it will take like 1.5 hour, 1 hour to do that, really. So you are welcome to come with your laptop and play with that, so you can get these results. Yeah, this is actually very nice. I'm sorry I cannot play it here, but these are like very colorful and so on. And now we don't have much time, so we'll go quickly through the ray merging technique. Ray merging is a ray tracing. Thank you. Is a to the stuff. There is a question whether. Oh, come on. Okay, no. I have to finish precisely at 1. Okay, so this is an intro that was done with this technique, ray merging. It's three-dimensional video with in real time, in which you have these reflections and so on. So it's an example of real-time ray tracer, and this is an intro which in the animation file has 80 megabytes, but it is written as a fragment shader and put into executable file, which is of 4 kilobytes large. Now I will try to play it at the very end, but let me now go through this technique. So ray tracing is everything about finding a collision between rays and between the scene. So to produce picture like this on the right hand side, you have to send a ray from the camera and find a collision between this ray and the object in the scene, so that you know what amount of the light is actually reflected from the light sources into your eye. And the very big problem in ray tracing is finding this collision. One of the techniques is ray merging. Ray merging is like going along the ray, so that you step by step go along the ray and try to find collision. So if there is my viewport and I send a ray, and this ray may collide with my object. One way is to find it by some analytical functions of collisions and so on, and algorithms. But there is a simple way, which is ray merging, but it was originally very slow, because you would need to ray merge along each individual ray in your scene. With GPUs and fragment shaders is great, because for each individual pixel, you have to run the same program, and you basically run it million of times, and it produces very nice results. So this is iteration of the ray merging. You basically go along a ray. I will not go into details of mathematics of it. This is a ray formula. It's very simple. You basically find, for each step, you find a minimum distance from your scene. So you have to define your scene as a distance function. It's similar to the circle you had, but you have it now in 3D. So you do spheres and stuff like this. So for instance, if we start from this point, and this will be the last thing I want to cover here, is you have to find the distance from the circle in 2 dimensions. You usually would do this way. In 16 steps, you would go through the entire scene to see this ray goes into the infinity. Now, with distance fields, you may use some trick, or this is not a trick, there is a scientific paper about it, very famous, that you may use a distance function to make larger steps. You may go like this, because you already know from distance function what is the minimum distance from any object in your scene, and you can proceed 1 step like that. You can proceed like that, and in 4 steps, you have it. It's very clever. And this is all I want to have it there now. It's really enough, and you can start playing with the ray merging. So this is an iteration, and you can produce with the code like this things like planes, which looks like that. You can produce spheres, which looks like that. You can sum it. You can do some shadows, which is basically summing up how much is covered by light, and you produce pictures like this. And this is the code that produces the sphere on the right-hand side. So you basically have three-dimensional ray tracer written on one page in a GLSL, and this is example code. And you will work with it in during the next part workshop. And to do something more complicated, use the so-called constructive solid geometry. So you multiply, divide, sum, and do things like this to make, for instance, coffee cup. And the next part is 130. With those of you who want to start some playing with that, it's in the fourth. You don't have to spend 2 hours here. Come to 15 minutes. You can also do something fancy and just to learn a little bit how to start. You can go to your room. You can do the MAGFest shader competition. So you are all welcome to submit your entries for the MAGFest. There is a deadline. It's tomorrow morning, 6 a.m. because at 10:30 tomorrow we have the prize giving. There will be a screening in this room. 10:30. You are all welcome to see what people did. We have two categories: for people from MAGFest and for people from Demoscene, who are doing remote entries for this compo. And if this all goes well, so we hope to have some nice things here. But don't worry, do it simple and don't go into trouble of doing something. Wow, you know, we are all learning, and this is the purpose of this. And I want to thank the Polish Cultural Institute in New York and the Polish Embassy in Washington for supporting our stay here. And the workshop download is here. You can make a picture if you like, or I will give you these details also in Baltimore one for you at 1:30 in half an hour. Thank you very much.